Hello. So we'll start with the this project, which is basically about migration of a JBoss kitchen sink application to a microservices with MongoDB. And this was a challenge which was given. In this challenge, basically, this is what I have done. This is a documentation which I've created. It's more of a design document and a little bit more than that, covers all the aspects, all the components which have been created. So we'll just go through the table of contents, which is like introduction, requirements, overview of the legacy system. Uh, what was also like where it was lacking, we'll cover that, and propose overview of the new architecture, the new components which are there, architectural diagram, and authentication and authorization. How we are going to cover those aspects. When we are going with microservices, then what all components which we have created, and additionally on the front end side which you have created, and additionally other aspects of observability like logging, tracing, etc. Okay, so let's get started. The first application which was given to me was about kitchen sink application. This application is about uh, this is mainly a old technology based application which was just about saving the user's information. It was just a kind of a registration but does not have any kind of an authentication or authorization. This was the plain UI member registration form where you can input name, email, phone, and then all the members would be displayed over here. And anyone without any authentication can click on this link and see all the users which have or members which have been registered. Internally, it uses H2 in memory database, and this was the structure of that database. So there was a single table which includes four columns, which is ID, phone number, name, and email. And the ID is a big int, and then varchar, and varchar. Okay. Now, about this, in this application, the different layers which were present are persistence layer, a service layer, controller layer, REST layer, web layer. Configurations of deployment and all were not pretty much there, but I had to figure out. And then some utility layers and all. That's it. Now, where it was lacking is it's not built on new technologies. It does not have auditing features. It does not have like authorization, authentication. It does not have other features like rate limiting, retry, and all of that. And it's more of a monolithic application. We need to break this monolithic application into microservices, and this is the new proposed architecture because a microservices architecture gives you many multiple benefits. And after breaking, these are actually it has been broken down into mainly six microservices. The one is configuration server, gateway, authentication server, user service, and then there is an admin server, which is basically a monitoring service, which is nothing but a Spring Boot admin server, and then the front end application. And these remaining ones are like the applications which are required by the running the top six microservices. Okay, so we'll just go through the architectural diagram. The architectural diagram here is like this. There is a front end application built on Angular. This is the new architecture now. Front end application only talks with the gateway. Gateway is working as a proxy, and it's basically acting as a front end for the backend. And gateway is the one which takes the request and also does the authentication. So mind you, it's just doing the authentication, not the authorization, right? For open endpoints, it does not do that as well. It just uh, reroutes the request coming in for the open endpoints to the respective services. So gateway is doing that. Additionally, gateway is also doing features like rate limiting with help of Redis cache. We store like how many, whatever is the rate limiting configuration which you have configured, it stores a count in the Redis. And right now we are doing rate limiting with help of IP. So it checks the IP, how many times that IP has hit, and based on that, it will rate limit. It also has a retry mechanism. If any of the downstream services is down, it will retry. Talking about auth service, as the name suggests, is for authentication, and it connects whenever a login request comes, the gateway routes that request to auth server. Auth server, because it does not connect to the database, it redirects to user service and request for the detail. And this internal communication happens via API key, which is secured API key. It does not happen with the help of JWT, but help of API keys. Now user service gives that information to the auth service, and auth service validates it, and then it creates a token and gives it back to the front end. Now when we are talking about this, how this whole process works, we'll see in the detail. But talking about user service is just holding the data of the users and managing the user domain. Configuration server is about managing the configurations. It connects to Git and Vault, HashiCorp Key Vault. Git is storing the non-secure informations like URLs and all, and Vault is storing basically all the keys, passwords, everything. So it's basically all confidential information over here in Git. Now talking about monitoring tools which we are using like Spring Cloud Admin Server, which is used for monitoring all the applications. Then we also have Grafana, Loki, Tempo. Grafana is for dashboards, Loki is for aggregating the logs, Tempo is basically for your Zipkin, which is for tracing, and then for Prometheus is basically for Matrix. These are the legends, which is like which one is exposed service, which is the internal service. So these gray ones are all internal services and all. And we all know about the advantages of microservices architecture. It's all detailed out, but we can go through it. Now, talking about one of the main aspects of this application is authentication and authorization. For authentication purpose, we are using a EDDSA 25519 algorithm, which is usually very fast compared to other services, other algorithms which are being used. And the reason is it also provides the concept of using private key and public key. The private key is given to the authentication service. It only uses the private key, and other services for authentication purpose use the public key. Okay. Now let's jump onto the how we need to create the how we need to start the application. Let's jump onto the actual demo. For actual demo, I'm coming here and I have created like this is basically the source code. The admin server, auth server, everything front end is also available here. All the components are available, and additionally we have the documentation available in the design document and some screenshots which are available, and then some architectural diagrams and everything is available here, which we can go through if you want. Coming on to starting the service, we have this script. We have the script called as setup.sh. This has been completely detailed out in the README document, readme.md. It also tells like how to use the script if you do not know how to use it. So just if you enter it, it will give you all the options it has. Build is there. Builds the application and creates Docker image. Push, it also able to build and push the images. Docker up, as the name suggests, Docker stop, Docker dump, and clean. Clean kills all the Docker containers. It does not clean the Docker containers, but it deletes the Docker volumes. Okay. Now we'll go and start the application. For starting the application, we have a certain order which we have to follow, and for that it has been mentioned that first we need to start all the required services. So required services can be started with this command, which is docker up -r, stands for required. The moment we do this, it starts all my required services, which is MongoDB, Zookeeper, Redis, Vault, Kafka, Kafka UI. MongoDB is also working as a secured one. We can see in the Docker compose file. In the Docker compose file, I have passed in the credentials admin 123. Although this is for development, we have done this. but in production it will not be passed through like this. Like your actually service would be passing the build CI/CD pipelines and all would be passing these values. Next thing is all the applications have gone up, we have also created some key vault entries. Basically, all the passwords which were required by the applications to connect and private key, public key, those all have been created. That we can validate on the vault itself. So let's see the vault, what has gone in. So this is the vault. Let me just show you from this URL. So when we go to the base URL of Vault, which is starting at 8200, it automatically redirects. Let's see. Okay, it's starting because it is booting up first time, so it's taking time. So the token has been provided as root, which is again a very loose password or a token. Although we will in production we will not use this kind of a token, but fine. So now under secrets, our entries have gone in. So our entries have gone in for auth service, gateway, user service, everyone. So for user service, we can see like we have what all secrets which we have. We have JWT public key and client ID and client secret, which is basically for internal communication of the applications. So we can see what is the public key, and this public key, the moment we'll rerun the load vault script, there is one more script which is there. All these keys get rotated if you want to do it for security purpose. So user service is getting the public key, but let's see auth service. Auth service will not get the public key, rather it gets a private key, and private key is completely different. And public key is generated by using the private key itself. So we have seen user and auth. Here is the gateway service as well. Gateway also gets the public key. Fine. Now we have this application started. Now jumping on to starting the observability layer, all the services related to that. Here is starting all the services, which is Tempo, Loki, Prometheus, and Grafana. Tempo, I told you about Matrix, Loki for log aggregation, Prometheus, Matrix, Grafana for dashboards. Now all our required services are up. So we will start our application now. And to start our application, there is a certain order which we have to follow. So first we need to start our configuration server. So let's start our configuration server. So configuration server would be giving all these configurations which are loaded in Git and Key Vault to all the services. Now we see configuration server is up, and we can validate the configuration server is up by checking the endpoint, which is here. And if we just reload this URL, I hope it came up. Yep. So this is for auth service, shows the private key, and these are the configurations coming in from the Git repo in the local environment from the application.yaml, and this is again coming from the Git repo but on the root level. The root level is common for all the environments, and this one is specifically for the local environment. In the Git repo we also have other environment configurations. So we can see the Docker configuration, which is on Docker server. The URL is Docker config server, gateway service, and like that. Similarly, on local, the URLs are pointing to localhost. Just loading it. Yep, these are all localhost configurations. So now our configuration server is up. Let's start our admin server. Just give it a minute. So admin server actually starts on 8877. So let's open that. So this one we have already seen. Let me. Is actually my system is becoming very very slow. It's like a lot of fan is coming up. Localhost 8877, and over here it has not started yet. Sting time. Yep, it is taking a lot of time. Finally, it is up. Let's see if we can open this endpoint. So perfect. So no applications have been registered yet. Now we will start the gateway. The applications which will register on admin server are auth and user service. Gateway is not registering on the admin server. If you want, we can do that. But to keep the gateway light, I didn't register that. And now we are starting auth. I think gateway is up. Starting the auth service. Once the auth service and user service starts, they will basically register on the admin server, which we will be able to visualize. Bit slow. So it's starting, it's exposed, and it started. So auth service automatically got registered on this admin server, and once this user service also comes up, it will also register. Okay, so it got registered. So both these services are registered, which we can see over here. How many from what time they have been registered. Let's open auth service. In auth service, we can see all the details, configuration server, all these details, disk space, everything is visible, right? Like we can see also the threads, memory, heap dump, everything. We can see the environment details. They are like starred, and we cannot see them. Although we know like what all details are going in, and if we want, we can expose them as well. Then there is logger informations, all the loggers which have been registered, what is the level, and dynamically if you want to change their level, we can do that. Additionally, for JVM, we can see these thread dumps, which is just taking a thread dump in the live. It does not keep taking it all times. This is just a live monitoring, does not have any database to store. And heap dump, it does not do it because it takes a lot of toll on the system. If you want, we can enable it. And these are all the mappings which my application exposes. So similarly, we can see for our other application as well, user service, but we'll skip it. Now let's jump on to front end. For the front end, we have to start the application by calling ng serve. Once we start it, it will start on port number 4200. Okay, sorry, we are not in that folder. Let's go in that folder and then start it. Okay, it's just starting up. So by this time, like we would be having somewhere around 17, 18 services running. Apart from this, like there are other softwares which are also running, like Mongo Compass, Mongo Atlas Compass, to visualize our database. So now the front end is up. The front end is up on this port. We can see it came up. Okay, it's reloading again. Yep. So there is this route, login and register routes are there. There is one register route where you can register a user. If we want, we will do a demo with the new registered user. So let's first do with admin user. Let's go with the admin, and there are multiple validations which have been added. If I do not enter anything, enter a valid username. For password, again validation is there, and let's enter in this case. So all validations have been taken care on the front end and back end, both the places. Okay, I've hit it again twice, so it's maybe taking some time, because first time it takes a bit of time because it needs to connect with the Kafka. I'll tell you why it is connecting with Kafka. So we are able to log in now. After logging in, if I want to see my own profile, the admin wants to see his own profile. Here he can see it. So this is his profile section. If he wants to modify his phone number or any other detail, his name as well, uh, admin buddy, and his phone number as well. So there is a validation on this phone number as well. If there is no phone number, save gets disabled. If we enter these letters, save still is disabled. If we enter letters and number, still it is disabled. All it needs is numbers. So now it is modified, name has been modified. Okay, going to users endpoint, which is basically only available for admin. It is not available for users. Admin can see all the users, and it also is an endpoint with search capability, along with that pagination as well. So in the network tab, we can see with whatever I search in admin, or let's search this buddy. So if I search this buddy, I get only one user, which is directly coming from the database. And here in the response, we can see it's only one response which we are getting with a pageable response. Okay. And if I want to see a regular user, which is user, so this would be this. All these are sorted. Right now it's sorted by ID descending, sorted by ID ascending. So these all requests are going on the back end and getting the sorted information. Its front end is not doing it. So by full name, email, phone number, creation time, all is can be done. Now because this guy is an admin, he can do a delete as well of a regular user. If we want, we can do it. Let me show you the delete. Do you want to delete this user? Yes, I go ahead and delete it. Now if I go in the users, I see only single user. Now let's log out and do a register. In register, let me register with a new user, which is Rahul Soni. Username is Rahul. Rahul is again sorry, the username is a indexed field on the database, and it's a unique field. You cannot have same user number, so username. Phone number is, let's if I do not enter it or is not in a format, it gives me this error. If the email is not valid, it gives me the error. It needs at the rate something, then it will work. So all these validations have been added. Okay. Similarly, over here in the phone number, this is not valid. So all these validations have been added. Password cannot be empty. This has also been done. Now let's enter a password. Let's say it's a simple password. Just a minute. This is a simple password. When I try to register it, I have added a clause for OTP, which would be sent to the email. But as of now, I have not implemented it, so we can enter anything. It was simple to do it, but due to time constraints, I couldn't do. I could have created a demo email server and send the OTP. Now we have registered this user. Now let's log in with this particular user. The user name was Rahul, and this was the password. Now we have logged in. As we can see, we do not have the users tab, so a regular user does not get that privilege. He can only see his own details. That's it. He cannot do anything much. And let's log out. So we did multiple transactions, logging in, logging out. Now let's see what happened behind the scenes in the logs. So uh, let me first show you This is Grafana running on port 3000, and in the explore section I have connected it, so I can just search with application, and I can search with any application which I want. Let's search for user service. So fetching the logs for it, so all logs are here. We can see when the logs are coming in. Now here is this one log which we are fetching a user with this particular ID, and if we want to see a complete tracing, we want to do a tracing of it, there is this option tempo with which we are doing a tracing. So when I click on this tempo, this panel opens up. Give it a minute. It is fetching the details from Grafana tempo, and we have the details. So gateway service is fetching the for this endpoint, it is fetching it. The request came to gateway, went to gateway HTTP get, and then from there it came to user service, and this is how it happened. So we can see like how much time it took. It took literally 29.22 milliseconds, and in the logs we can see which service is sending it. So user service sent it. Actually this log is generated by user service. This is the trace ID, and then let me close this section, and this is the span ID. So tracing has been implemented. This trace ID, if you want to see if from where this request originated, I can check with this trace ID on a gateway as well. So on the gateway, if I go to okay, what happened? Application. If I go to gateway and run the query, I think on the gateway I'm not logging it, so probably I'll not find it. That might be one reason. But let's search for auth for login. In login we will find everything, because regular things I'm not logging on the gateway. Gateway is mainly for routing and all. So audit event sent and all. Here we can see authenticated successfully. Yeah, let's open this authentication one. So this is the trace ID which is there in the gateway, sorry, which is there in the auth service. We found it, this user, and let's see the span ID. Span ID starting from 85 and ending with 7D. So let's find this trace ID in user service. Here we can find it, and the trace ID is matching, span ID is different, which is how tracing should work. And I can trace it that it started in auth service, gateway service, and then went to auth, and completely we can trace this whole request. So this is how it worked out. So additionally, like this application also sends out audit events to Kafka. On Kafka, this is the topic on which we have sent, and with a single partition. And because we logged in 3 times, we logged in twice with the admin, because that was a initially connecting to Kafka takes time, and I thought it's not working out, so I clicked twice. So admin event is coming twice and Rahul event is coming once. Here we can see the key is Rahul, username is Rahul, type login, result success, and created at this time. If we try to log in with, let's say, with Postman, and let's say we send a wrong event, I am right now on my Postman screen trying to hit it. So this is the gateway collection. I'm sending the wrong password. The password is correct. This is the correct. Let's make it incorrect by removing a 3. So it given unauthorized, and let's see on the Kafka, we should have a failure event by admin. So login failure event. These events can be enhanced to work on across all type of endpoints which are being exposed. Audit is completely a separate thing. It should not be included part of our application, because that's a completely a separate domain. And we should, ideally in a production environment, we should not do it from via the logs and all, because my downstream service which is doing the auditing maybe has a different need. It needs logs in a different way and needs the processing. Although it can be done, there's nothing stopping you, but uh, just generating the relevant events, which now the downstream system has complete control of. They can process the events however they want. They can run a service on top of it, replay the events. If they want to replay the events only for admin, they can do that. If they want to do it for a particular user, they can do that. For quicker access, they can save it on DB, expose the endpoint from that service, again going via the gateway. So a new audit service exposing a audit endpoint which is going via the gateway and can be seen on UI. So this is how it can be done. But this is not the only way. There can be multiple other ways how we can do this auditing. But in a relevant production size application, auditing is one of the important crucial factors. Like, if understand, if it's the bank, and in the bank if someone is doing a payment, so who logged in on the ICICI bank at what time, we can identify. If he is doing a payment, at what time he's doing it. So events are more reliable. In logs, what happens is the log files get rotated, sometimes are missed when we will go on the Kubernetes. So logs are not considered that reliable. Events are considered more reliable. That's one of the biggest reason. I learned it through the hard way while working in a 5G project, which was where the end users were Geo, Airtel, everywhere, every many other companies like Vodafone, Idea, and all. And this project was for HPE, and we were using logs, but it didn't work out. Finally, we moved into events. So because log get rotated at such a high speed, before you have read the file, the log file might have got rotated. If we even increase the size, some logs can get skipped. But in events, everything is bound to be captured. And now this Kafka can be exposed on completely on a different server. Like access can be provided, and auditing server can be completely different, where new services are being exposed on auditing side and all, completely up to us however we want to do it. But for a small service like kitchen sink, although not required, but to make it as a production ready, these kind of features are needed. So all this feature has been done. Additionally, I want to showcase like a couple of more things. Like Sonar also has been implemented. Right now Sonar is down. I would not like to turn it up, but if we want, we can see it in the, we can see in the documentation. So let's go in the documentation on the Sonar. Let's go into the gateway. So here we can see quality gates. So Sonar was done, code coverage was done, Jacoco and code coverage reports have been created. All the code coverage is above 80%. 80% I kept it as a threshold. So 89% has been done. And this is Jacoco reports as well. All this has been done. So basically we have covered all the aspects now. On the gateway, there are few more features which can be demonstrated. If you want, we can do it, like rate limiting and retry mechanism. So let me show you the code for gateway now. It seems to be a very industrial standards wise application has been created in that format. And basically here's my gateway config. In this gateway config, I am creating two routes, user service and auth service. And here I am configuring the rate limiting. Here I am configuring the authentication filter, which is there on the user service but not on the auth service, because auth service endpoint is login, which should not be authenticated. It should be open. So there is no authentication server on top of it. If we need rate limiting and retry, it can be added over here. I didn't add it, can be done. All we need is add that filter as well. Now retry configuration is also there. If we see the configurations for how these rate limits and all, yeah, biggest issue which I faced initially while working in this application was CORS issue. So this is how I fixed the course. Now these are the rate limiting thing which have been configured, and this is how retries have been configured. Retry is only 3 attempts. First back off, it's an exponential back off with 50 as the initial thing, and then 50 milliseconds and 500 milliseconds for maximum. And the exponential back off increases by the factor of 2, and this is rate limiting. So we can test the rate limiting as well. If we send in like first of all a real username password, we get this token. Once we have this token, we can use a utility which is called Apache Benchmark. Apache Benchmark is an open source tool. I can just replace the token which I received, and I can pass in with Apache. I'm sending like 30 requests with all in concurrent, and I'm hitting it. This endpoint which is get all users. For some reason, it is like all are going through, which is a bit odd. Ideally, it should not have gone through. Let me just check on the back end. How did they go through? Um, let's see in the logs. So the user service. Where is this? Okay, we are sending on 8080, correct, and we are sending this JWT token and hitting it is, oh, it's giving all non 200 responses. Okay, so it's 200, we are not getting it. Somehow uh, it is blocking us. The gateway is blocking us. So let's see. It's already giving us too many requests. So when initially it is giving us a 401. So 401 it is giving for admin, or it is giving us this 429, which is too many requests. So rate limiting is working, which is true. Let's see why this guy is not working, or maybe it's a other issue. I can just validate it. We can use another tool, http http 8080. Okay, I do not have a thing prepared. Let's send only one request, concurrency level of 1. So it's not going through. Okay, actually the reason is I have JWT here. I was setting the token in a token variable. I should have been doing this instead. This was my mistake. So here it is. We have this. So that's why everything was going into 404. Now let's hit this. Okay, perfect. So here we see we sent 30 requests, 11 have failed, and 10 have received non 200. So the failed ones include this as well. And let's see on the logs on here on the gateway. On gateway we can see 429, which is basically like too many requests, and there is some, maybe that's an older log here. So here we are seeing too many requests coming in. Let's clear up the log once again. Item. Okay, this time 12 have failed. So here, this is gateway, and on the gateway we are seeing only 429s, which is correct. So there are somewhere around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 have failed as per the logs. Maybe some have skipped. And on our user service, we can see all fetching the logs have gone through. So rate limiting seems to be working perfectly. And same way, if you want to test the retry, we can do it. Turn off one of the services down and retry would work. So this way I complete all the components and the complete requirement. And this is the documentation which has been created to demo. Logging, tracing, everything explained. Now let me tell you about the challenges which I faced. So it was a CORS issue which was a big time. Running the configuration server in a composite profile, which is basically like running multiple vaults per service, which I was not able to do. So within a single vault, I was creating a separate bucket for that. Then internal API communication was one thing which took some time, but I finally fixed it. Getting 401 versus 403s was a challenge. So my loggers were not working. My error handling was not working properly. So let's say we are trying to authenticate with user, and then from user, if I am trying to access a admin endpoint. Okay, what happened? I didn't get a response. Let me put it on remove the breakpoint. Oh, the reason is we have removed this user, right? Let me do this. But then also it should not give that thing to me. So this is working fine. If I completely send in a user which is not existing, okay, I think some response code issues there. Ideally it should have sent 401. Maybe I need to look at. Bad request. So all these areas have been covered. Now this user Rahul is a regular user. Let's get a token for this guy. And if we hit a endpoint which is only for admin, which is like search all users, and if I hit this endpoint, and in the params I'm passing is as a search term as admin or whatever, size, all this is just like that. We can pass in anything, but I'm getting 403 forbidden, and my logs global exception handling has been done. So my all logs come in this format, which is very relevant in our industry. Additionally, like mocking the UI URL. Actually, I wanted to send out dynamic URLs to the front end for the backend, but it was not working out. Front end always expects front facing URLs only. Future enhancements I could work up with CI/CD, but didn't get time. Service discovery with Kubernetes, which could have been done if I was getting some time to implement Kubernetes and Helm charts and everything. With Kubernetes only, I would have implemented auto scaling, horizontal pod scalars, and scalars for the node as well. Alerting mechanisms using Prometheus could have been done. I didn't work on that part. Log retention policies and alert retention policies and metric retention policies could have been worked out. Sending dynamic configuration updates via Spring Cloud Bus. So dynamic updates are not enabled. This is my GitHub repositories, Docker images which have been created, and then additional documentations which have been done. So overall, this is my complete demo. Thanks everyone.